Imagine if humans didn't need rocket ships to travel from Earth all the way to Jupiter. Imagine if we could communicate with extraterrestrial beings all the way at the ends of the universe in a snap.
The good news is, this might be possible in the future through something called quantum teleportation.
The process of quantum teleportation begins with quantum entanglement, in which two particles are connected by a wormhole or gravitational tunnel determined by Einstein's theory of general relativity. But that's a different story. It is important to note that quantum teleportation is independent of distance. Therefore, even if the two particles are at the opposite ends of the universe, the correlations between them and their quantum states are preserved. Also, even though it is called quantum teleportation, it is not really a form of teleportation, but a transferring of the quantum state of particle A to particle B through particle C while erasing the original state from A.
Essentially, quantum teleportation will still work even if we don't know what is the quantum state that we are transferring between particles. So how exactly do we transfer the quantum state of particle A to particle B through particle C?
Let's say particle C is on Earth and particle B is on the Moon. Particle A wants to travel to the Moon without riding a rocket ship, so we resolve to teleporting particle A. Assuming particles B and C are entangled, we need to entangle A and C by performing what scientists call a Bell measurement. The entanglement between C and B puts B in a state that can be turned into whatever state A is. Then an operation has to be performed on B in order to transform it into whatever A is. However, in doing this, the original state of A is erased from A itself.
But why does the original state of A get erased when it is being transferred to B? This is called a no-cloning policy that follows a fundamental principle in quantum mechanics that there cannot be two or more exact copies of any arbitrary or unknown quantum state.
But it is also important to note that information is not transmitted faster than the speed of light between any of the particles.
Now, the teleported object, however, is not the original object. It is actually a group of particles that have a 100% accurate copy of the quantum states of every single one of the particles that make up the original object. However, the teleportation of objects and living things is not yet possible because imagine the quantum states of the trillions and trillions of particles that make up objects and living things that have to be copied all at once with 100% accuracy. How else exactly can quantum teleportation be used?
It could also be used in quantum cryptography, where secret messages can be sent across great distances without being detected or intercepted.
So maybe one day it will be possible for humans to teleport across vast distances or even communicate with, say, E.T. or Marvin the Martian. Wouldn't you like to try that?
So science really is like magic, but real.